Hello, my name is George Fazekas. I'm a reader in semantic audio here at Queen Mary, and I'm the program director of Masters in Sound and Music Computing. This program is really for anyone who sits in the intersection of music and technology. People who are passionate about music, but also have a technological background, whether that's in computer science, electronic engineering, audio engineering, software engineering, mathematics, or an equivalent technological background in industry. So we have two streams, so it suits a broad range of interest. If you're interested in how AI and data are transforming today's music industry, for instance, streaming services, recommendation systems, or music distribution platforms, the AI and music data science stream would be the right one for you. And if you're more excited about building tools that musicians use, for instance, mixing consoles, audio plugins, hardware instruments, then the audio and music systems engineering stream is a perfect fit. Essentially, if you want to turn your love of music into a cutting-edge technological career, this is the program for you. The student takes two core modules, music informatics and music perception and cognition, which I think are unique differentiators.
I lead the module on music perception and cognition, which focuses on how our brains make sense of this really complex auditory signal that we call music, and also how they manage to find it pleasurable. From the basic elements of pitch, timbre and timing perception through communication of emotion, all the way up to how musicality evolved. By understanding how we perceive music, our graduates are able to build better tools that are designed to match the psychology of the users. Music is becoming increasingly technological, and we focus on teaching the skills needed for the next generation of engineers who are going to be building tools for both creating and listening to music.
In music informatics, the module that I teach, we cover how computers can understand music in the way that musicians do. So, for example, in terms of the rhythm, harmony, instrumentation, and we look at how these aspects can be extracted from an audio recording. For example, we look at algorithms for beat tracking, how to transcribe the music, so from an audio recording into music notation, and how to identify which piece of music it is that's playing. We cover state-of-the-art approaches using both signal processing techniques and machine learning.
The module I teach is Interactive Digital Multimedia Techniques from the stream Audio and Music Systems and Engineering. This module basically looks into human-computer interaction from a kind of digital loop theory perspective. This is a project-based module where students are exposed to theory with hands-on exercises, also sessions with code and hardware making, and all culminates with rehearsals and a performance. Reasons why you don't want to miss this module: one is that it's really truly interdisciplinary. Second is that you get to build a product, and then it has a real-world purpose where you will demonstrate your instrument in a real context with a concert.
As part of the MSc in Sound and Music Computing, students complete an advanced research project, which is where everything really comes together. And they do that with an academic supervisor. Recently, I've supervised projects on emotion decoding from brain signals, modeling pitch perception from transformer models, and music creation using diffusion models.
The career perspectives are genuinely fantastic. Our graduates have gone on to work at some of the biggest names in industry, including Spotify, Apple, Ableton, Yamaha, PlayStation, Rockstar Games, and others.
In terms of roles, we see our graduates becoming everything from machine learning engineers on the one hand, all the way through to starting their own startups.
The music technology sector is growing rapidly, and there's a real shortage of people who understand both the technical and musical sides. Our graduates are uniquely positioned to fill that gap.